Good afternoon, students. So yesterday I have told you some of the topics in the unit 1. That is, we have seen the relations, types of relations we have seen, how to represent the relation and how to find the Cartesian product. Okay. And after that, we have started even functions also. So what is the definition of a function? How will represent a function? And what is what are the conditions for two sets A and B, two sets to form a function. So how we'll find the mapping between the two sets A and B? We have seen yesterday what are the conditions, and the main condition for a two sets to become a function is that it should have the each and every element of A should have the image that is unique. Only single element it should have as the image in set B. Okay, and I have given some examples also, which is called as a function and which are not called as a function. Okay, the conditions are there, and even I have told what is a domain, codomain, and also range. Okay, so just we'll see in function only. So some names are there which are useful for solving the problems. So just to know that, so in functions only, so some terms are there. So please learn those terms. Okay. So if we have like this, yesterday we have seen the function definition and also example. Okay. So if A, B, C is there and 1, 2, 3. So like this mapping will be there. This is called as a mapping. Okay. We'll write this function as f is mapping from A to B. That means f is a function which is mapping from set A to set B. So whatever the elements are there, this I have told this as the domain. This is the codomain. And if codomain, whatever the elements, all elements, if they have the image, then we call this codomain is equals to range. Okay. So here whenever A is mapping to 1 and B is mapping to 2 and C is mapping to 3. Okay. So like this we have the elements. So we call here A, whatever it is there, it is pre-image for 1. Means these A, B, C, whatever the elements are there, these are the pre-images of 1, 2, 3. Okay. So we'll write this as A is pre-image for 1. Similarly, B is pre-image for 2. C is pre-image for 3. Okay. So like this. And also whatever here these elements are there, 1, 2, 3. These are called as images of A, B, C. Okay. So we'll write 1. 1 is image of. Okay. 1 is image for A. 2 is image for B. 3 is image for C. Okay. So means these are pre-images of this one. These are images of these elements. Okay. So that's why in terms of definition of domain and codomain and also range, we use the terms pre-image and also image. Okay. So when all the elements in the set B, if they have the pre-images as A, B, C, okay, then we call codomain equals to range. If we have one more element here, which is not having the pre-image here, then what we will tell, the codomain is not equals to range. Then range will be only 1, 2, 3, but not the element 4. Okay. So these are the some of the terms which we have to know for solving the problems and also theorems on functions. Okay. So after this, we have the types of function, which is very important. These types of function, it will be useful we have the last unit, that is a second, third, fourth or sixth, seventh unit are there, no, in groups. We have the fundamental, I have told in the introduction. It is a fundamental theorem of homomorphism we have. So there, if you know the concept of functions, then we have one-to-one function and also on-to function. That is, we called it as a bijection. So if you know here the definition of functions and types of function, then whatever the theorems are there, you can do the proof very easily. Okay, so whatever the concepts we are learning in the first unit, it is the basic foundation for other units, whatever second, third, fourth, fifth, sixth, even the rings, whatever the two blocks are there. If you know the concept of what is a set, what are the relations, what is the definition of a relation, and when we call it as a equivalence relation, the condition, and also whatever the function definition is there, and also types of functions. Types of function is very important, not only here, in some other your semesters also it will be very useful. So here, knowing of these concepts, whatever given in the textbook, it is very important. Okay. So basic knowledge, it is given in the first unit. If you know these all concepts, then whatever the theorems are there in the further units, you can solve easily. Okay. So in types of function, we have main three types are there. First one is the one-to-one function, second one is the on-to function, and third one is called as a bijective function. So one-to-one function means it is the concept whatever you have in intermediate. Okay, so one-to-one function is also called as injective function, and on-to function is called as surjective function, and also combination of one-one and on-to function is called as a bijection. On bijection, we have theorems are there, and also main important some problems also you have in your lab manual will be there, no practical classes. There also you have the problems on bijective function. So main bijective function, if you know the concept, whatever the homomorphism is there, sixth unit, there it will be very useful. Okay. So types of functions. So first one is the one-to-one function. So types of function, first one is one-to-one function. So it is also called as injective function. Okay, injective function. When we call it as a one-to-one function means, so whenever that is each and every element of set A, it should have distinct element or in set B. Compulsory one element from set A, it should have the mapping compulsory with only one element. Okay, with only one element of set B. That is called as a one-to-one function. So we call it as every distinct in the sense different. Every distinct element of A belongs to A. A belongs to A means A is the element from set A, must be mapped with distinct element of B belongs to B. Okay, means compulsory one element from set A should have only one element from set B. Okay, that is called as one-to-one function. We can take the example here. This is A, this is B, this is mapping from A to B. If we have A, B, C, 1, 2, 3. Okay, so single element should have only one mapping. Then we call it as a one-to-one function. Only one, each element, distinct, different element should have different mapping here from the set B. Okay. So yesterday we have seen what is a function conditions are there, no? If it have the whatever the element in set A, if it has two images in set B, then we will not call it as a function. Why? Because there also in the definition of a function, compulsory each and every element of set A should have the images in set B. Okay. So if you have function like this also, this is a function. First thing is this is function, and second thing is it is one-to-one function. If you have one more example, set B, say A, B, C, we have 1, 2, 3. If you have like this, A is mapping to 1, B and C, they are mapping to 3. Okay. So this is a function. Okay. Why it is a function? Because each and every element of set A, it is having only one image. That is, set B is having one image 3, set C is having one image 3. Here one element is left. If in set B, if one element is left also, then the condition is in set A, the whatever the elements are there, compulsory they should have the images there. Okay. If any element is left here, then it is not called as a function. But if it is left in the B, it is called as a function. Okay. So, and also if we have like this mapping, if A is mapped to two elements in the set B, then we will not call it as a function. But two elements, whatever are there, they can maybe mapping with one element in the set B. Okay, that is the condition. First thing, this is the function. It is satisfying the condition of the function, but it is not a one-to-one function. What is the definition of one-to-one function? Compulsory distinct elements of set A should be mapped with distinct. Here, what happened? Two elements B and C are, they are mapping with only one element. It is not the condition of the one-to-one function. It is a function, but it is not one-to-one function. Okay. So like this, you have to identify whether it is a function or whether it is a one-to-one function. Next, we have the second one. It is the onto function, or we call it as surjective function. So here we have in onto function, almost one-to-one and onto function are both are same, but just a slight difference will be there. So in some conditions, one-to-one function is also called as a onto function. Okay. But in some cases, what will happen here? One element is left. No, it is not one-to-one function. So not even onto function. Why? Because in onto function, compulsory whatever the elements in set B are there, they should have compulsory pre-image as, means they should have compulsory images in the set A. So no element in set B should be left. That is the condition for onto function. Okay. So just to reverse of that one, whenever it is onto function, here one element, if it is left, it is not onto function. Okay. So, but it will be here, if you see here, it is not onto, it is not one, but it is a function. Okay. Onto function. This is called as a surjective. So second one is onto, or we call it as surjective. Okay. So here the condition is that every element of B belongs to B must be mapped with element of A belongs to A. Okay, this is the only condition we have here. So, one-to-one function will be the onto function in some cases, but in some cases you will not see that one-to-one function because only one-to-one relation will be there. Here the element may be left, but here the element may be left here. So the condition is that every element of B belongs to B must be mapped with the element of A belongs to A. Okay. So for this we'll see the examples. So first one is example A, F. So like this you may have, and like this you can write. Okay. This is this is first thing is this is the function. Why? Because each and every element of set A is having the images here. Okay. And also the each and every element has only one single image here. So therefore, first thing is this is function. Okay. And also this is one-to-one function. Only one image it is only there. No, B is having 3, C is having 2, A is having 1. Therefore, it is one-to-one function also. And also this is onto one function. Onto function, what is the condition? Every element of B belongs to B must be mapped with element of A. So here whatever the elements are there in B, they are having the images here. Okay. Therefore, this is even onto function also. Next, we will see one more function. Like this, if you have A is there, B, this is, so if you have A, B, C, 1, 2, 3, okay. So A, 2, 1 we have, and here B and C both they are having the image as 3. Okay. First thing, this is the function. Why? Because A is having the image 1, B is having the image 3, C is having the image 3. One element of A should not have two images in B, but two elements in A can have as one image. That is a condition for the function. Okay. First thing, this is a function, and even all the elements, 3 elements, they are having the images here. So therefore, it is function. But it is not one-to-one function. Why? Because B and C, they are having only one single element. Each element should have only one image. That is the condition for one-to-one function. So this is not one-to-one. Okay. And even it is not onto function. Why? Because onto function, what is the definition we have? Every element of B should have, every element in set B should have the image here. But here 2 is not having the image, no? So that's why this is the not condition satisfied. Therefore, it is not onto. Okay. So here like this, we can see from the examples which are the one-to-one function and which are onto function. Okay. So next, combination of both. So you can take here this example. This is 1, 1 and onto, no? 1, 1 and onto means this is an example for bijective function. If it is satisfying both the conditions, then we call that it is a bijective function. Third one is 1, 1 and onto. It is bijective. If the function is both 1, 1 and onto, then we call it as a bijective function, and this is the best example for that one. Okay. So next we have many to one function. Many to one function in the sense many, whatever the elements are there in set A, means other than one. If two elements are having only one image, then we call it as a many to one function. Fourth one is many to one. So many to one function means multiple elements. Multiple elements of A should map with one element of B. Okay. So you can take the example here. A, B, and this is the function F. So A and B, other than one, you can take it as a multiple elements. Okay, like this C1 map. First thing, this is a valid function. So each and every element of set A is having the images in B. Okay. And also all the elements are having the mapping is there. So it is satisfying the condition. Therefore, first thing is this is function. And this is many to one. Other than one, you are having the two elements having only one image. So therefore, it is many to one. Many to one. And also, it is onto function. Each and every element of B is having the image here. But it is not a one-to-one function. Not one-to-one. Okay. So like this, you can see RL single three elements also you feel they are mapping with one only, then it is also called as a many to one function. Next we have identity function. So this is identity function is very important. So in solving the theorems also it is useful. Okay. So identity function. Okay. Identity function is if all the elements of A are having image as itself. So image of itself means whatever the elements are there here, same elements if we have in set B, then we call it as a identity function like this. Okay. So that is F is mapping from A to A. This is the indication and definition of identity function. So if all the elements of A are having image of itself, then we call it as an identity function. And the last one is that constant function. Okay. This also you will see in theorems. So constant function means whatever the elements are there in set A, if they have only one image, if all the elements of A are having same image, that is only one same image, then we call it as a constant function. Sixth one, constant function. Okay, if all the elements of A are having same image. So you can take example like this. A, B mapping from F. If A, B, C are there. If they have only one same image. One. Okay, this is the example for constant function. So first thing, this is a function. Why? Because each and every element of set A is having the image here. Okay. So this is a function. This is not one to one. Why? Because three elements having only single image, and this is onto function. Onto function concept is set B empty should not be there. It should have compulsory images. Okay. And this is the example for many to one. Many to, best example for many to one. More than one we have. Three elements are having only one single image. Okay. So these are the concepts we have in functions. So these are the very important one. Next, composition of functions will be there. Composition of function means just how you will have the multiplication of two functions. Similarly, in functions, we'll call it as a composition of two functions. So composition of functions means combining two or more functions. Two functions may be there, or three functions, or four functions, like that. Means more than two functions. If you combine them, we call it as a composition of functions. So F circle G, G circle F, you have seen in lower classes. It is in intermediate we have. There you will have concept of the composition of function. Okay, next, composition of functions. Composition of functions. Okay, it is called as combining two or more functions. So combining two or more functions is called as a composition of functions. A to B, G from B to C. If we have H, C to B, like this. So F circle, G circle, H. First thing is F circle, G. Next we can write G circle, F. Next F circle, G circle, H, like this. Combination of anything. Okay. So this is called as a composition of functions. We'll see one example. On this you have the problem in your textbook. So if f of x equals to 3x plus 1 and two functions only, we are seeing g of x equals to 2x. Okay. Then find for this, if it is f circle g of x. Okay. So how you will write this means, f you take out the circle and you write g of x. Okay. So what is g of x value? G of x value is 2x. So whatever this value is there, 2x, this 2x is called as a, that is x value is here 2x. So wherever x is there in function f, you have to substitute it as 2x. So if you substitute this, you will get it as like this. What is the f? 3 into, what is the x value here? 2x plus 1. So 3 2 just 6x plus 1. Okay, this is f circle G. Then if you find the G circle f of x, that is G of f of x. Okay. Now G of what is f of x? F of x is 3x plus 1. Okay. That means wherever G value is there, there you have to write in place of x 3x plus 1. So when you substitute in 2x in place of x 3x plus 1, what you will get? So it is equals to 2 into 3x plus 1. So 3 to the 6x plus 2. Both are same now? No, here 1 is there, here 2 is there. That means therefore, we can tell F circle G is not equals to Z circle F. The composition of these two values will be not equal, okay? The values will be different here. Now, in this only, we have one more concept, that is inverse of a function. This is a very important inverse of a function. So, for this inverse of a function, you have problems are there, and also on these theorems will be there. So, inverse of a function. Inverse of a function. Okay. F of x is a function, then its inverse is whatever the function you are writing f from a to b. If it is the inverse of the function, then we'll write f to the power of minus 1 equals to b to a. That means from set b to set a, if you write, it is called as a inverse of a function. Okay. F of x is a function, then its inverse is f inverse of x. Okay, the steps will be how to find the inverse of a function. If any one of the function f of x is given, then how we will find the f inverse of that function means in that we'll see some steps will be there. Means to solve that one, we need some 4 steps are there. So if you follow them and if you remember them, then easily you can find the f inverse of x. Okay. That means if f of x is, f is mapping from a to b, then f inverse will be mapping from b to a. Okay. Like this you can see. And here steps to find f inverse. Steps to find f inverse. Okay. F inverse of x. First one is so f of x will be given like this. F of x equals to ax plus b. Okay. So f of x equals to ax plus b. Then f inverse of x equals to y. Okay, if f of x equals to any function given like that, step 1 is initialize the equation to y. Initialize the equation to y. That means y is equals to ax plus b, you have to write. Step 2 is, that is replace x by y. And y with x. So wherever x value is there, there you have to write y, and wherever y value is there, there you have to write x. Step 3 is solve the equation for y. Equation for y. Okay. Next, fourth one is replace y with y with f inverse of x. Okay, these are the 4 steps to find f inverse of x for the given function f of x. First thing is initialize the equation to y. Means here whatever the function is there, f of x equals to ax plus y. You have to write y is equals to ax plus b. Replace x by y and y by x. Means here x equals to ay plus b. And solve the equation for y. So for whatever the value of y is there, there you find the value and replace the y with f inverse of x. So we'll see one problem on this. Then you can understand this one. So you have problem in textbook also. You can see there. So example, f of x equals to 5x minus 3 by 2x plus 1. Okay. Find f inverse of x. So here solution, first thing is whatever the function is there, you have to initialize f of x as y. So y is equals to fx minus 3 by 2x plus 1. This is the first step. What is the second step? Second step is replace y by x and x by y. So x equals to 5y minus 3 by 2y plus 1. Okay. Then solve the equation for y. That means you have to find the value for y. So if you cross multiply this, what you will get? 2xy plus x is equals to 5y minus 3. So you need to find the y value here. So here y value is there, here y value is there. So you can write this as 5y. If you take this 2xy that side, minus 2xy is equals to, you will get x plus 3. Okay. This if it will go there, you will get it as a minus of that value. So that is x plus 3. So 5y, if it will go there, it will be minus 2x. Here x is there already. If you take this 3 here, you will get it as x plus 3. Implies here if you take y common, it is 5 minus 2x equals to x plus 3. So what will be y? Y is equals to x plus 3 by 5 minus 2x. So even this you can write it as y. Okay, implies or else it is equals to x plus 3. Here first if you take x term means minus, if you take common it is 2x minus 5. Okay. Now replace y by f inverse x. So therefore f inverse of x is equals to minus of x plus 3 by 2x minus 5. So like this you have to find the f inverse of x. Okay. First thing is replace f of x value as y. Then you will get this one. After that, initializing f of x as y. Then replace x value as y value as x. Then solve for y. Whatever the y value you are getting, that is called as f inverse of x. Okay. So this by this we are completing the concept of functions here. So last concept you have in the first unit is that what are the prime numbers, what are composite numbers, what are relative primes, and also what is a GCD, that is the greatest common divisor definition, and what is division algorithm, and addition modulo we have, and also multiplication modulo we have. These all concepts you have in your textbook in solving the theorems. So if you know the definition of what is prime number, what is composite number, what is the greatest common divisor, what is the definition for addition modulo m and also multiplication modulo m, and also congruence modulo m we have. Okay. So if you know these all concepts, on this you can solve the problems and also theorems based on these concepts. So today we'll complete the unit 1. Tomorrow we'll start the unit 2, which is about the groups. So these are the basic foundation concepts for solving all the theorems which are there in blocks 1, 2, 3, 4. Okay. So compulsory you should know these all definitions and the concepts here. Okay. First one is the prime number. So prime number you have studied in the lower classes. So the numbers which are not divisible by, so the whatever the numbers are there, if they have only positive divisors of n, which have 1 and itself as a divisors or factors. The numbers which are having 1 and itself as the factors, we call them as a prime numbers. Okay. An integer n is called a prime number, is called a prime if n is greater than 1. Whatever the n value is there, compulsory it is greater than 1, and the only divisors and the only positive divisors. Okay, positive divisors of n are 1 and n. Okay, and the only positive divisors of n and are 1 and n. N means in the self itself. Whatever the number is there, if the number is having the only divisors as 1 and itself, then we call those numbers as the prime numbers. You can take the example here. 2, 3, 5, 7, 11, 30, so on. Okay. So whatever these elements are there, these are called as the, whatever these numbers are there, these are called as prime numbers, because 3, what have it has divisors? It is divided by only 1 and 3 itself. So factors also, if you see, 3 is having the factor 1 and itself. So whatever the numbers they are having the divisors or factors as 1 and themselves, they are called as a prime numbers. This is called as even prime. And whatever these all are there, these are odd primes. Okay. Next is the composite numbers. Composite number means other than the whatever the prime numbers, other than prime numbers, whatever the numbers are left, those numbers are called as the composite numbers. Okay. If n is greater than 1, is not a prime. If it is a not prime number, then we call it as a composite number. Then n is called a composite number. Then n is called a composite number. Okay. So you can take the example here. Whatever are left, those all are, that is 4, 6, 8, 10, 12, so on. Okay. So whatever the numbers are there which are left by the prime numbers, those are called as a composite numbers. Next we have relative primes, or we call it as a co-primes. Relative primes are co-primes. So relative primes are co-prime means if the GCD, greatest common divisor of two numbers, if it is equals to 1, then the two integers a and b are called as a relative primes or co-primes. So if a comma b equals to 1, this whatever the symbol is there, brackets we have, it is called as GCD. GCD means greatest common divisor. If greatest common divisor of two numbers is equals to 1, then two integers a and b are relatively prime. Relatively primes or co-primes we call them. Okay, you can take example here, 5, 14. Okay, these are the two numbers. If you will find the GCD, greatest common divisor, in between these two numbers, you will get only one as a common divisor. That is, only with one you can divide these two numbers. Other than that, no other number will be divided by these two numbers. So therefore, the greatest common divisor of these two numbers equals to 1. Therefore, these two are called as a relative primes or co-primes. Okay, or co-primes. Since 5, 14 GCD equals to 1. You can take even 4, 7. Since 4, 7 GCD is 1. Okay. Next we have whatever the definition is there here, GCD. Greatest common divisor means if A, B are two integers, not both 0, a positive integer D is called as the greatest common divisor of A and B, denoted by A, B. So when we call that is A, B are greatest divisor, they have as a D, because conditions will be there, two conditions. If it is satisfying that, then D is called as the greatest common divisor of two elements A and B. Okay, greatest common divisor. We call it as GC. Okay, like this it is represented in the books. Let A, B be, let A, B two integers, not both 0. Okay, a positive integer, D is called the GCD, that is greatest common divisor of A and B. A and B denoted by A, B. Okay, greatest common divisor means it is denoted as like this, A and B. If first condition is that is both should have whatever D is there, it should divide A and also it should divide B. That means D is common divisor of a common divisor of A and B. That is D should divide A and also D should divide B. This is the first condition. If the number D is dividing both the numbers A and B, then it is called as the greatest common divisor. And second one is every common divisor of A and B is a divisor of B. Second one is every common divisor of A and B is a divisor of B. Okay. So this is the condition we have here. So you can take the example. If 2, 3 and 6 are the common divisors of common divisors of 18 and 24. Okay. If 2, 3 and 6 are common divisors of 18 and 24, when you divide this 18, that is 2 2 and 3. In 2 it will go 9 times and 3 it will go 6 times. Here 2 it will go 12 times and 3 it will go 8 times. So like this. And even 6 3s are 18, 6 4s are 24. So 2, 3, 6 are the common divisors of 18 and 24. Also 2 divides 6 and also 3 divides 6. Okay. And also 2 divides 6 and also 3 divides 6. So 2 3 times and 3 2 times. So therefore 18 comma 24, whatever it is there, for this the common divisor is 6. Okay. So the common divisor for 18 and 24 is 6. Like this, with the help of this, whatever the statement is there, like this you can find the GCD. And another one more method is, in lower classes we have seen 18. If you do the GCD of this one, 18 ones are 18. So 6 no, 6 into 18 means 6 threes are 18. So 0. So this is called as the GCD, greatest common divisor of 18 and 24. Like this, by this easy method also you can find the greatest common divisor among the given divisors, which is the common divisor for two numbers. Okay. So this is the concept of greatest common divisor. Next we have division algorithm. On division algorithm also we have the there is the theorems are there. So division algorithm is in 10th class or intermediate you have this concept. There is Q is equal A is equals to QB plus R. So this is called as a division algorithm. This is the division algorithm. This is given integers A and B with B greater than 0. With B greater than 0, there exists unique integers Q and R such that A is equals to QB plus R. So this whatever representation is there, A equals to QB plus R, this is called as the division algorithm. Okay. Such that A equals to QB plus R with 0 less than or equals to R less than B. Okay. So if this whatever representation is there, this is called as division algorithm. So here this whatever the values are there, A, Q, B, R. So their representation is there. Here integers Q and R are called the quotient and remainder. Q is the quotient and R is the remainder we have. A is the dividend. Okay. A is the dividend and B is divisor. A is the dividend, B is the divisor, Q is the quotient, R is the remainder. That is called as a division algorithm. Next, most important one on these theorems will be there in the groups and also in the rings. You have that is the addition modulo M and also multiplication modulo M. Addition modulo M. Addition modulo M means it is represented as like this. Plus M. So in textbook you have N, so you take here N. Addition modulo N. Okay. Let A comma B belongs to integers. Okay, Z is the integers and N be positive integer. Then So addition modulo n will be represented as like this. A addition modulo n b equals to r, where r 0 less than or equals to r n. Okay, 0 is less than or equals to r less than n is the remainder is the where r is the remainder when a plus b, okay, is divided by n, is divided by n. Okay, a plus b is divided by n is called a addition modulo n of b. Okay, addition modulo n of b. Okay, this is called as a addition modulo n of b. So r is the remainder when a plus b is divided by n. Okay, when a plus divided by n, whatever you are getting the resultant, that is called as a remainder, and we read it as a addition modulo n of b. Okay, similarly, so you can take here examples, that is 1 plus 4, 2 is equals to 3. So here a plus b equals to r, that means a plus b, a plus b means here 3, 3 divided by n, what is n, n by 4. Okay, so whatever the resultant you are getting, that is here 3 here. So if we take here 2 plus 4, 5 is equals to 3. Okay, 2 plus 5 is 7. So a plus b means 2 plus 5 is equals to 7. 7 is divided by 3. 3 2s are, sorry, 4 no. 4 means 4 ones are 4. 4 ones are 4. What is the remainder? Remainder is a 3 here. Okay. So like this, we have to find the addition modulo n. If it is 3 plus 6, 3. It is equals to 0. Why? Because 3 plus 3 is 6. So 6. 6 means 1 is 6. So your remainder is 0. Okay. So like this, we need to find the addition modulo n. So next one is the multiplication modulo n is there. So multiplication modulo n. Next to multiplication. So it is represented as like this. Yeah. Okay. Same definition will be there. Let a comma b belongs to z and n be positive integer. Then a into b here. Okay. Then in a into b is equals to r, where r is the remainder when ab is divided by, okay, when ab is divided by n is called, is divided by n is called a multiplication modulo, a multiplication modulo, multiplication modulo n of b. Okay. So examples are here. 4 into 3 of 1 is equals to 1. That is 4 into 1 is 1. Divided by 3 means like this, if you will see 3 ones are 3. What is the remainder? Remainder 1 here 3. Okay. Next 2 into 2, 5. So this is equals to 0. 2 into 5 is 10. If you divide by 2, 2 5s are 10. So your remainder is 0. So like this, we will find the multiplication modulo n. Okay. Last concept in this is congruent modulo. This is also very important. So by this we'll complete the unit 1. So tomorrow we'll start the unit 2. So just one last topic we have, congruent modulo. Okay, congruent modulo means consider a positive integer. Consider the positive integer m if a and b are two integers such that m divides a minus b, such that m divides a minus b, that is m divides a minus b. Okay, like this, m divides a minus b, then a is said to be congruent to b. Then a is said to be congruent to b. Okay, congruent to b modulo m. Okay, it is denoted by, we'll write like this. A is congruent to B modulo M. Okay. This is the representation of congruent modulo. That is, A is congruent to B mod M. Okay. This relation between A and B is called congruent relation. This relation between is called congruent modulo M. So if M does not divide A minus B, if M does not divide A minus B, then we say A is not congruent to, no, A is incongruent between them, okay? A is incongruent to B modulo M. That is, we'll write it as A is not congruent to B mod M, like this, okay? So we'll see examples here for congruent modulo and also incongruent modulo. So minus 7 is congruent to 3 mod 5. So this is A here, this is B, and this is M. Okay. So what should be condition? M should divide A minus B. What is M here? 5. A is what? Minus 7 minus 3. So it is equals to 5 by minus 10. Okay. 5 divides here minus 10. Therefore, A is congruent to B mod 5. Okay. Now second example is here. If 25 is there, is not congruent to 4 mod 6. Means here M is 6. 6 by 25 minus 4 means it is 6 by 21, which is not congruent. Okay, like this. Not congruent to 25 minus 4. That is 6 is not congruent to 25. Okay. So this is the example for congruence and this is the example for incongruent. So these are the topics, almost each and every topic I have covered in the unit 1. So tomorrow we'll start the groups definition, and also some theorems are there in that, which are 5 marks questions you will get. So in this, some problems you will get in the symmetric difference is there, no? A union B, associative law, commutative law, distributive law, De Morgan's law. There some theorems, some problems you will get for 5 marks. Other than that, all concepts you should know to solve the theorems in next further units. Okay. So tomorrow we'll see the second unit.